OSPF, that is an Interior Gateway Protocol, IGP, and commonly used in large enterprise networks, guys. That is a link state routing protocol and provides fast convergence and an excellent stability. To find the best path, OSPF uses Dijkstra algorithm and uses the cost value as the metric. OSPF has fast convergence and an administrative distance value of 110. In an OSPF running router, guys, we have three main tables, and they are neighbor table, topology table, and the routing table. The neighbor table keeps the list of directly connected and OSPF running neighbors. Topology table keeps the topology map, which lists of all possible paths for a destination, and it should be same for routers in the same area. On the other hand, routing table keeps the best paths for destination. Okay, so we have mainly two types of OSPF design, and they are single area and the multi-area OSPF. Okay, in a single area network, all routers belong to just one area, and that is mostly the backbone area, which is area 0. Okay, this kind of design is suitable for small-sized networks mostly. The second OSPF design option is multi-area OSPF. In this design, guys, we have more than one areas, and other areas must connect to area 0. Okay, so this design is suitable solution for large networks to decrease the processing overhead. Okay, so let's have a look. Let me grab my pen very quickly. Okay, so here you are able to see we have area 0 still, same like in the single area OSPF design. But on top of that, we have area 50 and area 60. So what you need to make sure in here is the areas except area 0 should be connected to this backbone area, which is area 0. Okay, so you could see that area 50, it is connected to the area 0, and area 60 is connected to the area 0 by R3. Okay, by the way, those routers are known as the area border router. An area border router is a router that is located near the border between one or more OSPF areas, guys. So it is mainly used to establish a connection between the backbone area and the other OSPF areas. So it is a member of the main backbone network and the specific areas to which it connects. So let's have a look. We have area 50, area 0, and area 16 here. So for example, we have area border routers, then they are router 3 and router 2. Those are the routers connecting to area 0 to the other areas, which is 60 and 50. Okay, and pay attention that router 3 has one interface in backbone area and other interface in area 50. Same applies to router 3. It has one interface in area 0 and other interface in area 60. Okay, so the role of the area border router is connecting other areas to the backbone area, and it has another feature also. Okay, so let's say the link between router 8 and router 9 went down. So for example, maybe the cabling issue or an issue with the router 9 interface itself, so whatever it is, let's say there is a problem within that link. Okay, so in this case router 2 will isolate the fault, so just area 50 is affected from the failure and makes the shortest path first recalculation. Okay, so only the devices belonging to this area will make the recalculation instead of every router in the network will do the recalculation. There are several types of packets exchanged between OSPF routers to provide communication each other, and they are hello database description, link state request, link state update, and link state acknowledgement. So let's start with hello. Hello packet discovers the other OSPF speaking routers on the common subnets and declares the parameters on which two routers must agree to become neighbors. Hello packets are also used to elect DR and BDR routers and send as multicast to 224.0.0.5 for IPv4 and FF02:5 for IP version 6. Guys, please pay attention that hello and that intervals must match on both routers to establish an adjacency between each OSPF running router. Okay, so for Ethernet links, default hello interval is 10 seconds and the dead interval is 40 seconds, but these intervals can be modified with the commands that you are seeing on the screen. Basically, you can go to the interface level by typing the interface and the interface name, and you can type the hello and the dead interval. You can modify them as per your need. But again, just make sure both sides of the OSPF routers should have these same hello and the dead interval values, otherwise they cannot form an OSPF neighborship. For the link state routing protocols, guys, it is essential that the link state database for all the routers remain synchronized. Okay, so this synchronization will begin as soon as an adjacency formed between the neighbors. So OSPF uses the DBD database descriptor packets for the same purpose. After DBD packets are exchanged, the router may find it does not have an up-to-date database. Okay, so the LSR link state request packet is used to request pieces of neighbor database that is more up to date. On the other hand, update link state update packet is used for sending specifically requested link state informations which are requested by the LSR that we saw in the previous slide. Okay, LSU packet can contain one or more LSAs, and they are router LSA, network LSA, summary LSA, and etc. OSPF requires acknowledgement for the receipt for each LSA, guys. So multiple LSAs can be acknowledged in a single LSA ACK packet. Okay. So the router ID, guys, there's something called router ID that is used to identify a specific device within an OSPF database and must be unique to prevent unintended OSPF database problems. Please note, router ID, that is not an IP address. It is not a part of any routable subnet in the network. Router ID can be determined in three ways. First, manual configuration. I can go ahead and type the router ID command to configure my router ID. Second, if there is no manual configuration, highest IP address on a loopback interface will be my router ID. Third, highest, if I haven't configured any loopback, highest IP address on a non-loopback interface will be my router ID. We have mainly 4 different OSPF network types. Okay, so the first one is point-to-point, which refers to a direct connection between 2 routers. The second one is broadcast multi-access, that is a connection between multiple routers over an Ethernet network. The third one is NBMA, that is a connection between multiple routers over a frame relay or X25 network. And we have lastly the point-to-multipoint, that is a network includes multiple routers over an NBMA with hub and spokes. Large local area networks that have many routing devices can produce heavy control packet traffic as link state advertisements are flooded across the network, guys. So OSPF designated routers are the collection points of LSAs and used to alleviate the potential traffic problem on multi-access networks. That is very important. This election is done on broadcast and the NBMA networks only. So let's say if there is no DR election, then what would happen? Each and every router would share the LSAs with each other. You could see in here. That is a mess. That is a lose of the bandwidth. Okay, on the other hand, if you have a centralized device and everyone sent this LSA information with this centralized device only, which is designated router, which means you will save the bandwidth. A BDR, backup DR, is elected in case the designated router fails, guys. Okay, if a router in an OSPF network is not a DR or it is not a BDR, it will be a, let me grab my pen, sorry again. If a router is not a DR or is not a BDR, then it will be identified as the DR other. Okay, so the DR routers, designated routers, will communicate with the DR other routers over multicast 224.0.0.5 address. Okay, and please pay attention that a router will establish a full neighborship only with DR and the BDR router. Okay, for the other routers, for example, if a neighborship will be happening between a DR other and another DR other router, let's say this is router 1, this is router 5, this neighborship will not be in full state. This neighborship will be in the two-way state. In the designated router election process, router with the highest interface priority is selected as DR and the second highest will be the BDR. So if there is a tie at interface priority, router with the highest router ID will be the DR and the second highest will be the BDR. And also pay attention that boot up sequence influences the DR election process as well. So I have this command in here. Okay, I'm going ahead and configuring an OSPF priority for my respective interface, and this priority will make sure which device become a DR. Okay, the highest priority device will be the DR. Between routers, authentication methods can be used for OSPF security, And we have two types of authentication, which are the simple password and the MD5. In simple password authentication, password is sent as plain text at update message. On the other hand, in MD5 authentication, password is determined by MD5 algorithm, and that is the most secure method to secure the OSPF. So how I am doing the OSPF MD5 configuration is like in the screen. I am going to the router OSPF and the process ID in the config mode. The command is router OSPF1. And then I am typing area and the number of the area authentication message digest. Then I am going into the interface level and typing IP OSPF message digest key 1 MD5 as whatever key you would like to configure. Okay, that is how it really works. In OSPF version 2, guys, there is a command which is the network command, is used to specify which interfaces on a router will participate in OSPF and to assign them to a specific OSPF area. So the command is typically used in OSPF configuration mode. So I'm going ahead and typing router OSPF and the process number, router OSPF1, and then I am typing the network commands. Okay, so this command is used to specify which interfaces in this router 2 will participate in OSPF. Okay, that is the main purpose. And we have the passive interface command. Okay, that is used to disable sending updates out from a specific interface. So OSPF does not send hello packets on interfaces configured with passive interface command. So passive interface command provides security and efficient use of resources such as bandwidth. Okay, so if you have a look onto the screen, for example, for router 1, I have my this interface and I have my gig 00 interface, right? So this gig 00 interface is not connected to a router. It is connected to a switch. Okay, so that is why there is no reason that I should send hello packets from this interface down to the switch, because this switch will never respond to a hello packet, right? So that is why, for efficiency, I'm going ahead and just configuring the passive interface for gig 00, as you could see in the screen. So the command is router OSPF1 and I am typing passive interface gig 00. Okay, OSPF, guys, calculates the metric with cost value. So you can find the cost by dividing the reference bandwidth to the interface bandwidth. So, and according to the default OSPF metric, cost value calculation, the default OSPF cost for fast Ethernet interface and gigabit interface are assumed to be same. Okay, so they are both 1 for 100 gigabit per second, 40 gigabit per second, 10, 1 gigabit per second, and 100 Mbps all have the same cost, which is 1. Okay, so how you can verify it? The command is show IP OSPF interface and the interface. Then you should be able to see the cost of this interface. So since this interface is a 1 gig interface, the cost you should see should be 1, and it is shown like in here. So how I can verify the OSPF neighbors? The command is show IP OSPF neighbor. So When I type this within router 1, pay attention that I don't see an IP address, etc. I am seeing a neighbor ID. That is the router ID of this router 2, which is 2222. Okay, I am seeing the state of the OSPF neighborship. Okay, I'm seeing the dead timer as well as the address, which is the IP address this time of the router 2 interface, and I'm seeing the interface that I am connecting to router 2 as well. If you just want to verify the OSPF protocol itself, this time command is show IP protocols, and it will show you a lot of information such as what is the router ID, how many routers in this area, for which networks we are routing for, so on and so forth. So if you want to see some additional information such as the hold time between the SPFs and the minimum LSA interval, such information that you can use show IP OSPF command output.